So for someone listening, maybe wanting to break into one of these fields or perhaps level up, what are the ways in? How do you actually build these skills?
Right. Navigating this definitely needs a bit of strategy. Your sources lay out, well, both the traditional academic routes and these increasingly important alternative ways to qualify, which is great news, especially if you're thinking about changing careers.
Let's start early then. What about high school students? How should they prepare if they're interested in this?
Yeah, building that strong academic foundation early on is just critical. The absolute core subjects are computer science, mathematics, and statistics. And it's not just about passing the classes. These subjects teach the fundamental logic, the analytical thinking that underpins everything in data science.
Which specific math topics are most important, would you say?
Linear algebra, calculus, and definitely probability and statistics. That's the theoretical bedrock. Understanding those helps you understand how the algorithms actually work later on. In computer science, getting some programming experience, especially with Python if possible, is a huge advantage. But honestly, even a solid foundation in programming principles using another language, like Java and AP Comp Sci, is great. Python syntax is relatively easy to pick up once you have those fundamentals. And high school is also a great time to start playing with data science concepts directly. Learning about collecting data, cleaning it up, analyzing it, visualizing it, maybe trying small projects, analyzing some public data sets. Just cultivating that critical thinking and data literacy early makes a big difference.
Okay, what about university? Are degrees still the main path? And how necessary are advanced degrees like masters or PhDs?
Formal education is definitely still a primary route, yeah. And your sources strongly suggest an increasing emphasis on advanced degrees, especially for those more specialized roles or leadership positions. For a general data science role, a bachelor's in something quantitative data science, CS, math, stats, engineering is often the entry point. But as we noted earlier, the data suggests many careers, particularly the advanced ones, are increasingly asking for a master's or even a doctorate. That rise in job postings needing graduate degrees. It signals the field is maturing, and for certain competitive roles, a bachelor's might not be enough anymore. It pushes people towards higher ed for that deeper theoretical edge. For a machine learning engineer, a bachelor's in computer science, software engineering, or something similar is usually the minimum. But again, a graduate degree often provides that extra depth and project experience that can fast-track you to senior roles and better pay. It gives a competitive advantage. For a data engineer, most entry-level spots need at least a bachelor's. CS, engineering, even business with a tech focus are common. Degrees specifically in data science or analytics, with coursework in databases, data modeling, big data, highly relevant. For moving up, a master's focusing on data systems, analytics, or an MBA with an analytics track is often preferred or even required for more senior roles. For an AI engineer, given the complexity, a bachelor's in CS or data science provides the foundation. But for really understanding AI principles deeply and tackling those cutting-edge challenges, a master's or PhD in AI, ML, or a related field is highly recommended, especially for research or highly specialized roles, and for those specialized data scientists. While a quantitative bachelor's is common, many of those high-paying specialist careers increasingly require an advanced degree. Master's programs in applied data science, AML focusing on areas like computer vision or NLP or business analytics are very relevant. And it's worth noting, some master's programs are specifically designed to help people transition from non-STEM backgrounds too.
Okay, but what if someone doesn't have that traditional academic background? Or maybe they're looking to switch careers entirely. Are there other solid options to get the needed skills?
Oh, absolutely. This is where things like industry certifications and all the online learning platforms become incredibly valuable. They offer structured, flexible, and often very accessible routes to getting specific job-ready skills. This is particularly good news for career changers or people needing to upskill effectively.
Tell me more about certifications. How much do they actually help?
They can help a lot. Industry certifications act as a clear signal to employers that you possess specific, validated skills and knowledge they're looking for. Earning a respected certification, say from AWS or Google Cloud or Microsoft Azure, can really boost your marketability because it proves hands-on competence with their platforms. For machine learning engineers, cloud provider certs focused on ML are strong options, though some require prior experience. Certs from companies like Databricks also validate skills in specific ML tools and workflows. For data engineers, again, cloud platform certifications are really popular. Microsoft Azure, Google Cloud, AWS all have them. Your sources also mention some beginner-friendly options, like a metadatabase engineer certificate or programs like IBM's data engineering certificate that are specifically designed for career changers, sometimes with no prior experience needed. For AI engineers, certifications range quite a bit. You've got introductory ones covering AI fundamentals, sometimes without even needing coding skills. Then there are more advanced ones requiring Python and diving into specific techniques or deployment practices offered by IBM, NVIDIA, and others. And for specialized data scientists, platform certs like the Azure Data Scientist Associate validate cloud skills. There are also project-based professional certificates and nano degrees on platforms like Coursera or Udacity, which are great for building a portfolio and proving you can use tools like Python and SQL effectively.
Right. And what about online courses, those MOACs? There seem to be thousands out there.
Yeah, massive open online courses, MOCs, are fantastic for flexible learning. Platforms like Coursera, EDX, DataCamp, Udacity, they offer courses and full programs, often from top universities or tech companies. For machine learning, you can find comprehensive specializations taking you from beginner concepts to advanced deep learning, usually with hands-on coding labs using Python libraries like scikit-learn, TensorFlow, PyTorch. For data science, there are tons of beginner-friendly professional certificates covering the fundamentals: SQL, visualization, data wrangling, intro ML, using tools like Python and R. Google and IBM have very popular entry-level programs. For AI engineering, you can find courses covering everything from basic AI concepts to advanced deep learning, NLP, generative AI, MLOps, often tied to specific cloud platforms or tools. And for data engineering, platforms like DataCamp and edX offer structured paths covering SQL, database concepts, Python, big data tools like Spark and Kafka, and pipeline orchestration tools like Airflow. Many include practical exercises.
That's great. Are there also good free resources people can tap into, maybe just to start exploring or go deeper on certain topics?
Absolutely, tons. YouTube is actually an incredible source of high-quality free content if you know where to look. For the crucial mathematics for data science, channels like 3 Blue 1 Brown offer amazing visual explanations of things like linear algebra or neural nets. Others provide great stats tutorials or break down the math behind specific algorithms. For ML and data science tutorials, channels like FreeCodeCamp, Data School, Data Professor offer practical guides using Python, Pandas, R. Others focus specifically on machine learning implementation. And for industry insights and advanced topics, you can find channels summarizing the latest research papers, doing deep dives into advanced tools, or featuring interviews with leading AI experts like Lex Friedman. These are fantastic for self-directed learning, staying current, and just deepening your understanding.
Okay, this has been incredibly comprehensive. So it really sounds like there isn't one single right path, but maybe different strategies work best depending on your goals and the specific role.
Exactly. That dual path seemed to emerge pretty clearly. You can aim for broad versatility, understanding and contributing across the data lifecycle, or you can choose to go deep, cultivating highly specialized expertise in one of those complex, in-demand AI subfields. Both are viable paths to success, but they might lead to different types of roles and earning potentials, especially right now with the AI boom.
And that choice between being a versatile all-rounder or a deep niche specialist.
Which really brings us to a final thought, a question for you listening. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world?
So, last of the big four. What about the traditional data scientist role? Is that still a thing, or has it kind of dissolved into these more specific engineering roles?
It's definitely still a thing, but it's also evolving. What we're seeing is many data scientists are specializing. They're diving really deep into particular business domains or specific advanced techniques to solve very targeted problems. And that specialization, it often leads to higher pay precisely because that niche expertise is so valuable.
How do they generally differ from the MLEs, AI engineers we just talked about?
Fundamentally, data scientists use analytical methods and tools to pull insights and knowledge out of data. Their job often starts earlier in the process, figuring out if the right data even exists. Is it useful? Then collecting it, cleaning it, often dealing with really messy, unstructured stuff, initially categorizing it, and then doing deep analysis. A core part of their work is developing, validating, and refining algorithms and models. This might include machine learning models for things like classification or prediction. They spend a lot of time testing model accuracy and reliability and updating them as new data comes in.
And how do they share what they find? How do they influence decisions?
That's a key skill, translating complex analysis into clear, actionable insights for everyone, technical colleagues and non-technical business leaders. They rely heavily on data visualization, creating charts, graphs, dashboards to present their findings effectively. The goal is often to make data-driven recommendations that guide business strategy.
Can you give some examples of how they might specialize?
Sure, some might focus heavily on building recommendation systems, for instance, or developing very sophisticated ML algorithms, maybe leveraging a strong engineering background. Others might concentrate more on research and analysis within a specific business function, like marketing or sales, trying to improve customer engagement or optimize campaigns based on data insights.
What are the main challenges they typically face in their work?
Well, just structuring and cleaning that raw, often messy data is always a big hurdle. Developing and rigorously testing complex models to make sure they're reliable is tough. And effectively communicating really intricate findings to different audiences, that's a constant challenge. Plus, they often need to be quite innovative in finding solutions to problems that pop up anywhere along the data pipeline, from collection to interpretation.
What kind of qualities and skills make for a good specialized data scientist?
Beyond the technical chops, really strong analytical thinking is absolutely essential. They need solid computer skills coding, analysis software, algorithms, visualization tools. Excellent communication, as we mentioned, is vital for sharing results. Strong math and stat skills are foundational for designing and evaluating models, and they need really robust problem-solving and logical thinking abilities to navigate those complex data puzzles.
What tools are typically in their toolkit?
Python is king here too. Your sources say it's in something like 85% of job postings. SQL is also crucial for data retrieval, showing up in about 59%. R is still important, particularly for statistical analysis. Expertise in implementing ML and AI is obviously key, and your sources highlighted a huge jump in demand for deep learning and neural network skills recently. For frameworks, TensorFlow and PyTorch lead for deep learning, with scikit-learn essential for general ML tasks.
And on the data handling and visualization side?
Core skills definitely include data visualization itself, statistical analysis, and data mining techniques. For viz tools, Tableau and Power BI are very common, along with Python libraries like Matplotlib and Seaborn. They often need to work with big data tools like Apache Spark and handle both SQL and NoSQL databases. Cloud platform skills, AWS and Azure especially, are also becoming increasingly valuable for data scientists.
What does the career path look like for these specialists?
The path often progresses from maybe a data analyst role up through junior data scientist, senior lead, potentially reaching chief data scientist. Other options include moving into consulting or even executive roles like chief data officer.
Okay, wow. That's a fantastic, really detailed look at these key roles and where things seem to be headed.
Which really brings us to a final thought, a question for you listening. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world?
How does the AI engineer role fit in? A bit different from an ML engineer?
It is, yeah. They're typically more specialized. AI engineers kind of sit at that crossroads of data science and software engineering, but their focus is laser sharp, developing, implementing, and maintaining specific AI solutions, especially in complex areas like, say, natural language processing, NLP, or computer vision. They're really central to getting advanced AI models built, trained, and deployed to tackle tough, often cutting-edge, real-world problems. And they're always thinking about making these models robust, scalable, and capable of learning over time.
So how does their day-to-day differ from an ML engineer's? Is there much overlap?
There's definitely overlap, but AI engineers often grapple with even more complex or specialized kinds of data, maybe from Internet of Things devices or vast amounts of social media text, and they might use more sophisticated or newer algorithms. Think things like transformers, which are key for the large language models everyone's talking about, or intricate deep learning setups. They're building these advanced models for very specific demanding tasks like sophisticated recommendation engines or highly accurate predictive systems. Data prep is still vital, but the pipelines might be even more complex, pulling from more diverse sources.
And collaboration must be key here too.
Absolutely essential. They're constantly working with cross-functional teams. Data scientists might provide the initial spark or model idea. Software developers help integrate the AI into actual products, and stakeholders ensure it aligns with business goals and user needs. That multidisciplinary view is really important.
What happens after an AI model goes live? Is their job done?
Not at all. Monitoring and maintaining these live AI systems is a massive part of the role. They're focused on optimizing performance, making sure it scales under varying loads, analyzing user feedback or performance data, and rolling out updates to keep the AI effective as the world changes.
What are the unique challenges they really struggle with?
Well, beyond the usual suspects like messy data or complex algorithms, a really critical challenge is that balancing act. Balancing peak model performance against real-world constraints. Things like, how much does it cost to run this thing? How quickly does it respond? Is it scalable? And increasingly, ethical considerations are huge. Ensuring fairness, protecting privacy, deploying smoothly without causing an unintended harm. That constant optimization while juggling practicality and ethics, your sources suggest that's often the biggest hurdle. It really pushes the role beyond just research into practical, production-ready AI.
Okay, given how advanced this sounds, what kind of technical skills do AI engineers need?
Strong programming is a given. Python, yes, but often Java and C++ too, especially when performance is critical. They need deep expertise in a range of advanced ML and deep learning algorithms. Frameworks like TensorFlow and PyTorch are standard, of course, but what often sets them apart is expertise in specific AI domains. And the tools used there, like, say, Hugging Face or LangChain for NLP, or specialized computer vision libraries, and experience with large language models, OpenAI's models, Llama, etc., that's becoming super important. Plus, managing the whole development and production infrastructure, including cloud deployment at scale.
And outside the core tech skills?
Well, strong problem solving is crucial for tackling these novel AI challenges. And like the other roles, excellent communication is vital for working across teams and explaining what these complex AI systems can actually do.
How does the career path look?
Starts junior, then AI engineer, maybe AI team lead, or up to AI director. But people might also specialize further, becoming a deep learning engineer or a computer vision engineer, or move into designing the overall systems as an AI architect. Just fueled by how rapidly AI is being adopted across pretty much every industry, tech, finance, healthcare, you name it. A really critical insight from your sources is this. The demand for AI experts, particularly in those cutting-edge areas like generative AI or deep learning, is currently outpacing the supply of qualified people. So the clear takeaways here are, 1, AI engineering is maturing fast and facing a real talent crunch, especially in specialized areas, which drives up salaries. And 2, that emphasis on balancing technical performance with scalability, ethics, and real-world deployment, it shows the role is evolving. It's not just about building the smartest model, it's about building responsible, practical AI systems that have a real impact. Which really brings us to a final thought, a question for you listening. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world?
Where do we even start trying to understand this whole landscape? It seems complex.
It is, yeah. The data science world is definitely changing rapidly. It's being pushed forward by constant innovation, but also this huge demand, right?
Wow.
Businesses need people who can actually turn data into action. And as companies rely more and more on data for decisions, we're seeing these roles become much more specific, more specialized. Your sources really highlight 4 roles that seem particularly crucial for where things are heading. So that's where we'll focus today's deep dive.
All right, let's get into those roles then. First one, machine learning engineer. What's their main job, their place in this evolving world?
Right. The machine learning engineers, or MLEs, think of them as the bridge. They take the theoretical models maybe from researchers or data scientists and they make them work in the real world. What's really key here, I think, is that they handle the entire life cycle of an ML model, from the very beginning to the very end.
The whole life cycle. Wow. What does that actually involve, like day to day?
Well, it kicks off with getting the data ready. That means pre-processing, cleaning it up, organizing all that raw info, dealing with missing values, getting it into the right format, normalizing it. Then comes building the actual models, selecting algorithms, training them on the data, tuning them so they perform well. And a really big piece is testing and validation, making sure the model's accurate, reliable, using the right metrics like accuracy or precision, or maybe means squared error depending on the task, and fixing problems like overfitting, when it works on the test data but fails in the real world.
Okay, and once it's tested and ready,
Yeah.
they actually put it to work.
Exactly. Deployment is a huge part of it. Integrating these models into the company's live systems, and that often means working really closely with software developers. But it doesn't stop there. They're constantly monitoring how the model's doing, retraining it with new data, and making sure it can scale up and run efficiently.
So it's not just building it, but keeping it alive and healthy, basically.
Precisely.
Yeah.
And that requires a lot of communication. Constant collaboration with data scientists, other engineers, and this is crucial, with the business leaders. They need to be able to translate business needs into technical specs for the AI and then explain what the model can and can't do back to the non-technical folks.
Can you give some examples? What kind of real-world problems are they tackling with this end-to-end approach?
Yeah, your sources mention things like predicting when factory equipment might break down based on sensor data, or forecasting customer demand using sales history to optimize, say, inventory or logistics. Their skill lies in picking the right algorithm for that specific business challenge and making it work reliably.
Sounds like a mix of skills. Is it mostly about the coding, or is there a lot of deep theoretical stuff involved too?
That's a really important point. While coding, especially Python, is absolutely essential for building things, the foundation is deeply rooted in math and statistics. Understanding concepts like probability, linear algebra, distributions. That's not just academic for an MLE. It directly shapes how they choose, build, and fine-tune models. They're basically translating math into code.
Okay, so when we look at their technical toolkit, what are the must-haves?
Python is number one, absolutely. You might see R mentioned sometimes, especially for stats work. Then for building the models, particularly deep learning, frameworks like TensorFlow and PyTorch are standard. Scikit-learn is huge for more, let's say, classical ML tasks. And for deploying and managing these models at scale, cloud platforms are vital. Amazon SageMaker, Azure Machine Learning, Google Cloud Platform, they need to know these. But beyond the tools, like we said, that solid grasp of the underlying math, linear algebra, calculus, probability theory, stats, that's what allows them to really understand why things work, not just use a library.
And what about the non-technical side, those soft skills for collaboration?
Oh, definitely. Strong analytical thinking, obviously. Problem-solving skills. But communication is just paramount. Being able to explain really complex technical ideas clearly, both to other techies and to business stakeholders, that's key.
Okay, sounds challenging but really impactful. So what does the career progression look like for an MLE?
The path seems pretty well defined. You'd usually start as a junior MLE, move up to an ML engineer role, then senior. After that, it can branch into management, like an ML engineering manager, or more technical leadership, like an ML architect.
In the overall job market, is the demand really there?
Exceptionally strong seems to be the consensus, high demand, and it's projected to stay that way. The U.S. Bureau of Labor Statistics predicts really significant growth, like 26% over the next decade for related roles, much faster than average. The whole AI and ML market itself is just booming, expected to be massive globally pretty soon. I think the key insight here is that waiting that entire model lifecycle from data prep all the way through deployment and maintenance, that's a seriously valuable skill set. It's not just about building clever models. It's about creating AI systems that are reliable, scalable, and actually drive business value. That combination of deep statistical know-how and practical engineering muscle, that's what's driving the demand and the high paychecks. A strong theoretical base is definitely valued alongside the hands-on skills.
Okay, that makes sense. So if the MLEs are building and deploying the models, who's wrangling all the data needed to feed them? That sounds like a huge job in itself.
That's exactly where the data engineer fits in. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world? The data science world is definitely changing rapidly. It's being pushed forward by constant innovation, but also this huge demand, right?
Wow.
Businesses need people who can actually turn data into action. And as companies rely more and more on data for decisions, we're seeing these roles become much more specific, more specialized. Your sources really highlight 4 roles that seem particularly crucial for where things are heading. So that's where we'll focus today's deep dive.
Who's wrangling all the data needed to feed them? That sounds like a huge job in itself.
That's exactly where the data engineer fits in. Think of them as the architects, the custodians of an organization's data infrastructure. They build and maintain the systems for collecting data, storing it, processing it, and, crucially, making it accessible. They basically build the data highways and the plumbing. You could say they're the absolute backbone supporting any data-driven company.
Right. So what are their main tasks on a typical day?
It really boils down to data management. They're designing, building, and maintaining robust databases, data architectures, and especially data pipelines. These pipelines are critical for pulling in large amounts of raw data from all sorts of sources and then processing it. A huge part of their job is getting that data ready for data scientists and analysts, making sure it's clean, accurate, usable. This involves everything from spotting inconsistencies to building automated workflows to clean and reshape the data.
So a lot of behind-the-scenes work to make the data useful.
a ton. You'll see them heavily involved in ETL extract, transform, load, or sometimes ELT processes, extracting data, transforming it into the right format, loading it into data warehouses or other systems. They have to merge data from different places, check it, parse it, clean it. There's a lot of coding involved, often focused on making things efficient and scalable. They build optimized data stores for analysis and set up ways to serve that data reliably.
Do they mostly work alone, or is it collaborative?
Oh, definitely collaborative. It has to be. They work very closely with business analysts, IT teams, software developers, and especially data scientists to really understand what data is needed and then build the right infrastructure to deliver it effectively.
What are some of the biggest challenges they face? The main headaches?
Just ensuring the data quality is consistently high, accurate, clean, ready to use, that's a constant battle. And handling the sheer volume of data, often coming in fast from many different places, and processing it quickly and reliably, that's immense pressure. Dealing with messy, inconsistent data is just part of the daily grind.
I've heard data engineers can specialize a bit too, is that right?
Yes, your sources mention that. You have generalists who kind of do everything data related. Then there are those who focus heavily on the pipelines managing the flow of data, and others who are more database centric, really specializing in designing and managing complex database systems.
Okay, let's talk tools. What technical skills are absolutely essential for a data engineer?
Python and SQL. Those are the absolute foundations. Your sources say they show up in, 70% and 69% of job postings, respectively? Yeah, critical. Other languages like Java, Scala, sometimes Go or C#, they pop up too, often for specific performance needs or system integrations. And deep knowledge of databases is a must. Both relational ones like PostgreSQL or MySQL, and NoSQL databases like MongoDB or Cassandra, plus expertise in data warehousing platforms Snowflake, Redshift, BigQuery are the big names there.
And for building those crucial pipelines you mentioned.
Yeah, they need to be proficient with ETL or ELT tools. These automate moving and transforming data. Your sources list things like Apache Airflow for managing the workflows, dbt Cloud for the transformation logic, and various cloud-native services like Azure Data Factory. And for really large data sets, knowing big data tools like Apache Spark and Kafka for processing is pretty much essential.
Cloud skills seem vital across the board. What's the focus for data engineers there?
Huge. Cloud expertise is absolutely huge. They need to be very familiar with the services on the major platforms, AWS, Azure, Google Cloud, especially the ones for data storage, processing, and management. AWS seems to have the edge in mentions and job postings according to your sources, but Azure is right behind it.
You mentioned DevOps skills earlier. That sounds interesting for a data role. How does that fit in?
Yeah, this is a really significant trend, I think. We're seeing more and more expectation that data engineers possess skills from the software development world. Things like CI/CD continuous integration, continuous deployment, and tools like Docker for containerization, Kubernetes for orchestration. It's not just a nice to have anymore, it reflects this key insight. Data pipelines are being treated like critical software products. They need version control, automated testing, reliable deployment, all the best practices from software engineering.
Gotcha. Are there other important skills besides the core coding and infrastructure stuff?
Definitely. Data modeling, designing how data is structured efficiently. Data governance and security are becoming increasingly critical, protecting data, ensuring compliance with rules like GDPR. API and integration skills are needed to connect to various data sources. And interestingly, your sources suggest even data visualization tools like Tableau or Power BI are showing up more. It implies data engineers need to understand how the end users, the analysts, and business folks are actually going to consume the data they provide. The path seems pretty standard. Starting maybe as a trainee or junior, moving to a mid-level role, then senior. After that, it can lead to leadership roles like manager of data engineering or deep technical expert roles like data architect. It's also quite common for people to move into data engineering from related fields like software engineering or business intelligence.
What about the job market overall? Still strong?
Yeah, strong and stable seems to be the message. Growth projections are consistently solid. It's a foundational role. Thousands of jobs are opening up each year. It's in high demand because every data initiative relies on them. So, the key insights for data engineering. One is that skills-first hiring trend. Practical ability with the tools often counts for a lot, which is great news if you're changing careers. And second, that growing need for DevOps skills. It really highlights how data infrastructure is maturing, adopting serious software engineering discipline to build reliable, scalable platforms. That blurring of lines means being adaptable is really key. Which really brings us to a final thought, a question for you listening. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world?
Welcome to the Deep Dive. Today, we're plunging into the world of data. It's everywhere, right? But how does raw information actually become, well, useful power for you?
Exactly. We're going to look at 4 key roles that make that happen. Think data analyst, business intelligence analyst, the DBA database administrator, and the financial analyst.
Okay.
We'll break down what each one really does, the skills they need, and crucially, how they work together, how they turn that raw data into, well, basically insights, and maybe touch on some challenges they face.
Sounds good. Let's start with the data analyst. I've heard them called data detectives. Is that fair?
Yeah, that fits pretty well. Their main job is grabbing raw data from, all sorts of places and then digging into it, interpreting it.
But it's more than just looking at numbers, right?
Oh, definitely. It's about finding the meaning, translating complex stuff into something clear, something that actually helps with planning or making operations better for you.
What kind of tools are they using for that detective work?
Key tools, yeah. SQL is huge. That's how they talk to databases. And languages like Python or R are really important for cleaning up messy data, which, believe me, happens a lot.
Right.
Imagine, an online store sees engagement dropping. The data analyst jumps in, looks at user clicks, site speed, purchase history, all that stuff.
To find the why.
Exactly. It's this back and forth, asking questions, digging deeper, refining the analysis, making sure the story the data tells you is accurate. That's vital.
Okay, so the data analyst finds the clues, cleans them up. Who takes that and turns it into big picture strategy? Is that the BI analyst?
You got it. The business intelligence analyst. They're the strategic storytellers. They take the process data.
The stuff the data analysts prepare.
Precisely. And they transform it into actionable insights. Think compelling visuals, dashboards, reports that execs can actually use to make decisions.
So less about the raw data, more about the so what for the business.
Exactly. They use tools like Tableau or Power BI. These make data really visual and intuitive. If customers are leaving, the BI analyst builds something that shows why, and maybe even which customers are likely to leave next.
So the sales team can jump in.
Right. It lets teams be proactive. It's about directly impacting business goals, driving growth. Very strategic.
Got it. But none of this works if the data itself isn't reliable or even accessible, I guess.
Absolutely critical point. And that brings us to the database administrator, the DBA, our data guardian.
The unsung heroes, maybe.
Often, yes. Their world is the entire data infrastructure, managing it, securing it, keeping it running smoothly. They ensure data is stored correctly, retrieved efficiently, and crucially safe.
Safe from what? Like hackers?
That, yes, but also corruption, accidental loss, making sure it's just there when you need it. They need deep knowledge of database systems. Think Oracle, MySQL, SQL Server, and robust security practices.
Can you give an example? Like when would they be front and center?
Okay, picture a big online sale. Black Friday, maybe? Traffic spikes? If the database slows down or crashes.
Disaster, right?
Total disaster. Lost sales, angry customers.
Exactly. The DBA is the one diving into server logs, maybe increasing connection pools, basically allowing more people in, optimizing queries, load balancing traffic. They prevent that outage or fix it fast. They make sure your data foundation is solid. Invisible, but essential. Okay, so we have clean data, strategic insights, and a secure foundation. Where does the financial analyst fit in? The market navigator.
Right. They take all this good data and the BI insights, but apply a very specific lens. Money. Investment, profitability, financial health.
So looking forward financially.
Yes, very much forward-looking. They guide decisions on where to spend capital, investment strategies, navigating the market. They're often masters of Excel for financial modeling.
Still Excel.
Oh yeah, Excel is king in finance, but Python and R are making huge inroads for more complex analysis, especially if the financial data is messy or incomplete, which it often is.
What's a typical challenge for them?
Forecasting is a big one. Building, say, a 12-month financial forecast based on past data, but also factoring in market volatility, making smart assumptions. It's about translating economic trends and company data into smart financial plans for you.
Okay, so let's tie this together. We've got these 4 distinct roles. But they don't work in isolation, do they?
Not at all. They're deeply interconnected. It's like a chain, really. The DBA guards the treasure chest and keeps it organized.
The data foundation.
Right. The data analyst polishes the jewels inside, cleans, and prepares the data. The BI analyst arranges those jewels beautifully in the display case, makes the insights clear and actionable.
And the financial analysts.
They use the value of those jewels, the data and insights, to advise the king on how to invest his wealth wisely. For growth, for stability.
That's a great analogy. And they must share some skills, too.
Definitely. SQL often pops up across roles. Data visualization principles are useful for most. Problem solving is universal. Communication, huge for all of them. But it's their specific focus and technical depth that differentiates them.
So the big takeaway is, this data ecosystem relies on all these parts working together smoothly.
Absolutely. Effective decisions, the kind that really drive a business forward, depend on this collaboration. Each role brings a unique, vital piece to the puzzle.
And thinking about the future, AI, machine learning, that's changing everything, isn't it?
It is, yeah. It's automating a lot of the routine tasks, the data cleaning, the basic report generation. But that doesn't mean these roles disappear.
It shifts the focus.
Exactly. It frees up humans for the higher level stuff. More strategic interpretation, asking better questions, focusing on the ethics of data use, really connecting the dots between insights and real business value.
So here's something to think about. With AI handling more of the data grunt work, what new really complex problems will you be able to tackle? What strategic frontiers can you explore when your focus shifts upwards?